This past week, we learned a very important calculation, and that is the confidence interval. Let's take a look at how we calculate this particular value. What does this formula actually represent? This requires us to understand some fundamental concepts. The first is random sampling. Suppose I drew random samples from a population and calculated the mean of each sample. Maybe the first time we get this mean, and then the next time we get a slightly different value, and so on, and so forth, and so on. This is unavoidable and is called sampling error. Interestingly, if we take an infinite number of samples of size n from the population and calculate each of their means, we would in effect be constructing a sampling distribution of sample means. An interesting thing happens. If we take repeated samples of size n, the sampling distribution of sample means will have a mean equal to the population mean and a standard error equal to this particular equation. This is called the central limit theorem. So, what is a confidence interval? A confidence interval is a range of values around a point estimate of a statistic in which we possess a certain level of confidence that we have captured the population mean. Returning back to the formula, when we multiply the z-score that represents 95% of the area around the mean and multiply this value by the standard error, we can then calculate the upper and lower limits of a specified confidence interval. Special note here, rarely do we know the entire population standard deviation, so we substitute this formula for this formula. And instead of using a z-distribution, we consider a t-distribution, a slightly different formula for standard error. In conclusion, when we possess a certain level of confidence that we have captured the population mean, we can then apply this logic to detect significant differences between groups. That is the focus of this week's material.